In this video, I want to talk about, or rather propose, a couple of big ideas for the conceptualization of multiplication. Use the term big ideas because I think it's important, because I believe it's important that teachers use these conceptual exposures or repeatedly over the long period of time that students are developing their their multiplication skills, starting with single digits, building to multi-digit. In fact, multiplication begins at the end of second grade with the conceptualization of groups and working with groups and identifying groups, moving clear into the sixth grade where students are expected to be efficient or fluent with all standard algorithms of multi-digit operations, which obviously includes multiplication. So I think these conceptualizations, or ones like these, should be used continually throughout the student's development. And the conceptualization should answer the question, or should help students answer the question of why multiply, which would help answer the question, which would help with problem solving in regard to when do I multiply, when do I use this strategy for dealing with numbers. Because up until this point they've used multi-digit addition, and they're able to handle really large sets of numbers pretty efficiently especially with the standard algorithm. So why do we need multiplication? And the answer to that is in this first. Really, I think grouping encompasses both strategies that are both ideas that I'm going to show you, that all multiplication really comes down to that. That's when multiplication is valuable to us, because if we're just looking at two sets of numbers, we add them up. But when we start to experience numbers that can be grouped, for instance, you get your first part-time job and you make $10 an hour. You're scheduled to work 5 hours one week. You know how much money you're going to make. That's a grouping problem. We have 5 groups of $10, 5 groups of $10, and so we can add 10 5 times, works, and it's not so bad in 5 times 10, but what about when we've worked 35 hours? Now it becomes highly inefficient. So students need to be able to see when grouping is appropriate. Then I can multiply, and it's a way of fast counting. So 5 times 10 equals 50 is much faster than adding 10 5 times or adding 5 10 times. So this grouping idea is really the big idea, and I'm going to show it 2 different ways. First one, we'll just start with a simple fact, and this is the way I'd start with kids, is have them take a fact 3 times 4. Maybe they already know it, but I literally have them draw out 3 groups of 4. And this, for most students, is a pretty simple activity. I would even have them circle my 1, 2, 3 groups of 4, count them up, and they're going to find out there's 12. Pretty easy problem. And a lot of people would intuitively say, well, this is simple, they see that, they're going to get it the first time, and that's not untrue. But we really want them to repeat this same thing over and over again over a course of several days, because what we're really going for is them fixing this grouping idea into their long-term memory. We want them to see multiplication as grouping, that what's happening is we're taking 3 sets of 4 items and adding them really quickly, so they're forming groups. So it's really the whole grouping thing that we're trying to drive home, not just the calculation of the fact, which hopefully they'll eventually get to a place where they memorize. And so it's just that simple. There's not a lot more to say about it. And then, of course, you can turn it around and do a 4 times 3, have them make 4 groups of 3, and then they see that they get the same answers. So if we're very early on, then you got a great inquiry-based question. Well, notice that I have 3 times 4, 4 times 3. I end up with the same items total. Let's have a conversation about that. And that conversation ends in the commutativity of multiplication. Then you get to division eventually, and they try to apply commutativity, and their minds are blown because it doesn't happen with division the same way. So that's one idea. Pretty simple, big idea. Say it, use it over and over again, but use the grouping language throughout. Even when you get to problems like, 27 times 48. Well, this is 20. I would continually repeat this. This is really, students, we have 27 groups of 48, and we need to find our total. So 27 separate groups of 48 items. And then their mind goes to here, I can't quickly arrange 48 items. Doesn't matter, I still understand what's going on here. 27 groups, each group has 48 items. Probably going to be a pretty big number. So see, we start to expand that development of the sense of number and the magnitude of number. The second big idea that's important with multiplication, and you'll see a lot, is the array Maybe there are different curriculums that call these different things. I've seen it referred to as an array. That makes sense to me. And really we have, just going to box this, it's not typically represented that way, but we have three groups of four, or we have 3 rows with 4 items each, and that gives us a total of 12, which is why I drew the box around it, just to show it's in totality. But we have 3 rows of 4 items each. Of course, the commutativity in here is just built in, because then now you can focus on, well, and then we have 4 columns of 3 items each, and we still have the same number. So that really drives home the point of commutativity, which simplifies the memorization of multiplication facts, because you really only have to simplify 3, or you only have to memorize 3 times 4. You don't have to memorize 4 times 3. Because through an activity like this, you'll drive the point home conceptually with students that 3 times 4, or so 3 rows of 4 or 4 columns of 3 give me the same numbers. That's only 1 fact instead of 2 that they have to memorize. So a lot of use for this one. It also obviously starts to build the concept of area, which becomes important later. Not just later, it starts to become important right away. But direct tie to area with this model. So I would use both of these, maybe switching back and forth, but use them a lot. You don't have to use these forever and ever, because they're not that hard. Students will get it. But just keep bringing them in every once in a while. And again, I think more important is continuing to reinforce the grouping strategy, as they get into larger and larger facts. So 27 times 36 is 27 groups of 36 items, a lot of items. Or we have 27 rows with 36 items in each row. Same thing. You don't have to always draw the picture. Once they practice this over several days, then the idea is that mental visual is always there. And our visual long-term memory is really much stronger than our auditory or than any other form of long-term memory. That visual aspect, if you can create that picture in their mind, that's really powerful, and their mind will always go back to it. So that's it for the big ideas. I want to emphasize the importance, and I know I've said this probably 20 times already, but the importance of continuing to infuse these ideas in their thinking, and also begin to contextualize them with bigger problem solving, using dollars, using whatever kids can connect to. Because we want to make multiple connections in their brain. It's going to help with problem solving, because what happens when you're problem solving and you're in more elaborative levels of math, here you have pretty basic math levels. It's not as elaborative, it's more declarative or procedural, so it's a little bit simpler, requires repetition. When you get into more elaborative, now your mind's starting to connect things that it's already knows. It's going to be searching for something that's similar. So like a story problem would be an example. Any story problem would be an example of something that's more elaborative. As students read the scenario, their brain's going to start to search for what the right tool is. And it needs to be able to find connections quickly. So if you've repeated these things multiple times and you've talked about and you've used these in several contexts, then students are going to find that more quickly and more easily and retrieve the correct procedure for solving more elaborative problems. And it really does work well. That really will work well for your students if you use these conceptualizations over and over again.